negative x?
It's not.
Is it the opposite?
Down. Oh, never mind.
Yeah?
Yeah.
And the line x equals 1. So there we go. Now when I reflect this, be careful, you still have a gap, right?
Yeah.
So it's going to look something like, on the other side, kind of a similar shape. But you have a shell on the outside. So this has a hole all the way through it. It's got no top, no bottom. Can you picture that? It's got thick sides, especially towards the one side, the right side. But it's got no top, no bottom if I were to turn that around. Completely empty right there. Yeah, kind of like a donut. Okay, but weird shaped donut. Because it gets thicker to the bottom.
Hey,
A donut is a donut. You're going to eat it regardless.
Okay.
Not true.
Whoa, wait a second.
Okay. Anyway. So, here we go. Outside, inside. And I disconnected. Why did you disconnect?
Because I felt like it. Sorry. What?
Here we go. Okay, so outside. Ah, there we go. Let's see, disconnect again.
Please don't die.
Okay, my radius. I can't see where I'm at. There we go. From the outside, so I go from the axis. You're always going the axis. That's the middle of the shape. To the outside. Which function is that? E to the x. Which will give me pi e to the 2x, correct? Power to a power you multiply.
Correct.
Inside, that inside radius just goes to the other function, yes? Which is e to the negative x. So I get pi e to the negative 2x. I'm going to go ahead and factor out the pi. I have the integral from what to what?
0 to 1.
0 to 1. It should be pretty easy because they flat out tell me my stopping spot is 1. Okay, so I'm going to have e to the 2x minus e to the negative 2x dx. Now both of these require different substitutions, correct?
Yeah.
But we should be able to figure out that antiderivative by now. We should be pretty good. What is an antiderivative?
1/2 e to the 2x.
1/2 e to the 2x. Not 2e, we have to compensate by 1/2. And you can check it. Take the derivative. E to the 2x times an extra 2, that'll make it go away. But if you want, you can break this up into 2 separate integrals and do substitution on each. Okay? If that confuses you. So minus over here, that'll give me,
Where would be plus?
Negative.
it will be, yeah, we're going to change it. It'll be negative 1/2 e to the negative 2x. The minus and the negative cancel. So now when I plug in 1, I'm going to get 1/2 e squared plus 1/2 e to the negative 2. Now everyone gets in the habit of plugging in 0. Oh, it's nothing. Not true. If I plug in 0 here, I get 1/2 plus 1/2.
Which is 1.
Right, which is 1. Okay. Let's see. These aren't very nice to clean up. Let's see if we can clean this up anymore. We may not be able to. That's e squared over 2 plus 1 over 2e squared minus 1. And some books will leave it like that. Some will find a common denominator. We'll go ahead and find a common denominator. I doubt it's going to help us, but we'll clean it up a little bit. This one needs a e squared. This one's good. This one needs a 2e squared. Yeah? I'm going to get pi times e to the 4th plus, I'm going to go ahead and write it in different order, minus 2e squared plus 1 over 2e squared. It's not pretty, but there's my answer.
Looks pretty to me.
They're not all going to work out to be nice things. And of course we could get a decimal approximation for this as well. But if you can give exact, give exact.
For problems like these, are we going to be required to show a graph on the AP test? Or how?
Usually, sometimes it will say if they're going to grade you on that.
Okay.
It will say graph and.
Do
But a
they
lot
have
of
to be,
times
like,
they give you
wonderful graphs, or do
a lot of times they give you the enclosed area graph and say find a formula for the area and then find a formula for the volume revolved about the x-axis. You're not required to draw the picture because they already give you the enclosed area.
But this